There you go. It's all
Since we're
you.
live. All right. So, like I was saying, this is a follow-up to 3 weeks ago where Craig showed us how to use an Arduino. And let me, yeah, I'm presenting to everyone. All right. Um, and so, I don't know if screen share. Yeah.
All
So we'll
right.
go back and we'll look at his code. Can we see his code?
Yep,
Are
I
you
can
guys
see it.
seeing that?
Yep.
Okay. This is actually my fork of his code. And so you can see I added a couple of things here we talked about, and I changed the speed. I did the same thing. I've got no patience for this stoplight thing. It sits there for 10 seconds at one point and it drives me crazy. So I put a scaling variable in there. But the thing that these very low level, these little 8-bit, 16-bit processors have in common, whether you're programming C or this is actually called processing, um, or even, God forbid, machine or assembly, is takes a lot of lines of code to do something like flash a few LEDs in the party mode or something like that. So um, the great thing is, I'm switching over here. I'll put the link to this out there. I've got just a Raspberry Pi demo GitHub here, and it's got several Python programs in it.
Cool.
It's got, the very first one I did here was to kind of show that you can write code in the exact same way using Python as you do, as Craig had to do for his demo. And this is like a very procedural thing. I'm setting up all the pins and all this stuff the same way he did. And then you go down here and you write out every last cycle of this thing, right? And so, I turn on the greens, and then I let them sit there for a second, and then I turn them off, and I wait, and I turn on the yellows, and I turn them off. That's one way of doing it. The interesting thing I learned this week was if you don't run this GPIO cleanup method down here, when you're
Mm-hmm.
done, your LEDs stay on. So that's kind of fun.
Huh.
You don't have that problem with Arduino. When you shut up, when you stop an Arduino, you stop an Arduino. Um, so the next version of this, I kind of put together, some fun names here: simple demo, better, and then I've got betterer. I do the same setup and everything in the top here, where I'm basically assigning pin numbers to variable names to make it easier to understand what's going on. But one of the first big changes, if you were to compare the two pieces of code, is I've got this all lights list, and I put every one of those lights in a list. And then down here, when I go to set up, I don't set up each of those pins individually. I set all the pins up together by passing that list to this method.
Okay. What is
And then
that?
the other thing,
What are you using? That GPIO? What is that?
GPIO is a module that's available. There's a couple of versions of it. This is the RPI. I imported up here, Raspberry Pi GPIO, and that is the module that allows you to interact with the pinout on the Raspberry Pi. So basically allows you to interact with the 40 pins or whatever it's got available.
Okay.
And so you just import that. You import as GPIO. The other thing I import is sleep, just so you can do the delay, kind of like we were doing with the Arduino.
Mm-hmm.
So those are the only two things you really need to do a lot of cool stuff here with just some LEDs and switches. And again, down here, the color groups, I set color groups up. So instead of, turning on each individual pin with its own line of code, now I can turn on all the reds at once and all the yellows at once and all the greens. So these two lines here are kind of interesting. You have to set the board mode, and the newer Raspberry Pi should be set in BCM, which stands for Broadcom, because they run a Broadcom system on a chip, and that basically allows you to interact correctly. The older one I have, my Raspberry Pi 1 or whatever it is, needs to be set up in board mode or something like that because it's the older version that has a 26-pin header. Another interesting thing is to set warnings. Like if I was to comment this out and run this, the program just throws all kinds of warnings about, hey, you're using this pin and this pin's already in use. And basically everything I read said, well, just set this so to shut the thing up. You know, I'm not sure what point the warnings actually serve. So,
Huh.
Yeah, it's kind of interesting. So, and so you see here, like it's a little more compact. So when I'm running through my while loop, you know, my infinite loop here, I've kind of got the same setup as an Arduino. In Arduino, you set up like a main loop that just loops constantly. And so I've kind of recreated that pattern here. And so I'm setting all the greens on. That's what GPIO high means. You can actually use 3 different things here. You can say GPIO high, I could say true, or I could put a 1 in there, and all 3 of those things will have the same result. I'd use the GPIO high just because I think of pins high and low when you do these things. So then I set all the pins, all the green pins low. We rest, we wait. Then I do the same thing here, and then when I hit Control C, it does that cleanup function and shuts all the lights off. So that's kind of the intermediate version of the demo. And then, come on. Then the better version, you have the same imports, it's the same delay time. We do everything else the same. We got all lights. This grouping is the same. Except this time I have this list called colors. And so instead of having all these on and off things for each color, I say for color and colors, repeat this. And so that's how you can take that very long, you know, Arduino style procedural code and crunch it down into a very short while and for that just loops over, you know, a list of basically pin numbers is all it's doing. So.
Okay.
You guys understand what's going on there?
Yeah.
Yeah, I think so.
It's pretty simple for Python code, but it takes something that, you know, that Arduino example, and it makes it much simpler to figure out what's going on, I think. So let's watch this run.
All right. Hey, TJ, thanks for joining us.
Hey guys.
Okay, so you're running the Python script now?
Yep, I'm going to run the Python script. So I've SSH'd into the Raspberry Pi from my laptop. The Raspberry Pi is running headless. It's not got a keyboard or anything attached to it. It's just got a network cable connected to it, and I just SSH into it. And so hit that. No one asked for my password. You, for some reason, when you interact with these pins, you have to be running as root. So now let me switch on my camera. If I can figure out how to stop sharing. Or go back to the Hangout. Oh! I guess sorry.
All right.
We're used to that.
Yep. Okay. So this is just the demo mode that we saw before. And that's running the betterer. And if I go in here, I'm gonna go back to the command line here and I'm gonna shut it down. I go back and I run better code, same result.
Okay.
And if you just run the good code, it's the same thing.
Now, as far as your board wired up, is it wired up similarly the way your breadboard is wired? Is it in a similar way to what Craig was doing the other day with his breadboard?
Yeah. Yeah, and I would tell you to look at his fritzing drawing rather than mine. I haven't completed mine yet.
Okay.
The key is I need to add. I have this header on my drawing that he does not, but it's got the same resistors. It's got the switch, same LEDs. What you can't hardly see here is I've got 3 green wires here going to the first light, 3 going to the yellow. Then I have one wire here going back to an input pin, which we'll use here in a second.
Okay.
And so, all those are very simple things. And then because I put that cleanup method in there, you can see it stops when I hit Control C. I didn't write it that way the first time. I just wanted to get it running. I was like, why did those lights stay on? And so I figured out why. And so the next little demo I've got here that I included is just a simple input demo. It's the most convoluted way ever to turn on an LED. And you run the program, and then when you push the button, I'm not sending current directly from the power source to the red LED. I'm sending a signal to the Raspberry Pi to send the power to the LED, right? It's like the worst way ever to turn on a light.
So
I'm sure we can come up with worse.
So the switch is triggering your code to turn the light on?
Yep. So when this switch comes on, there's a line of code that says if this switch is on or goes to high, because right now, one thing, I don't know how well you can see it, there's a little resistor there. Right now, this input is at ground, and so it's at low, or basically 0 volts relative.
Okay.
And as soon as I hit this button, it feeds at 5 volts. And so when that pin goes high, or it gets the 5 volts, the program says, hey, the pin's high, the input pin's high, so make the output pin high, or send 5 volts to the output pin.
Okay.
Can we see your code?
I also have a print statement that prints the switches on, the switches off, depending on All right, let's get out of this. Okay, let's go back here. I'll just show you the switches on, switches off thing. So you see it switches off. Every 1/10 of a second it prints the switches off. I hit the button and it starts printing the switches on.
Okay.
And I let go and it changes. And that could be something like we were talking a little bit earlier before the Hangout started. Like I could log that to a database. I could be running SQL Alchemy or something and running it to Postgres or something and just say, hey, at this time the switch was on, the switch was off, or whatever. So let's stop that, and then we'll go look at the code. So this one here is called Input Demo, and again, I'm bringing in the same 2 libraries that I have been. This time I'm only setting up one light, so I just define a variable for second red light because that was what it was called in the other programs, and that's on pin 26.
Okay.
The first time I ran this, one of these programs, it didn't work because I put pin 24 in there, so it makes it a very visual typo. That's the great thing about working with hardware, is if you expect pin 26 to come on and you get no voltage, it's probably in your code. And then I'm reading from pin 18, so that's my input pin. And at this point, I'm just giving them names. I'm not actually set them up in the code. I have the same board set up, set the warnings to false so it doesn't throw a bunch of weird warnings that don't mean anything. And then I'm setting up the light again, so I'm making it an output. So GPIO out means I want this pin to be an output. And then different from the rest of them, I've got a setup, the same method here. I'm giving it pin in, but I'm also saying, well, I want this to be an input. So it's like I'm listening on pin 18, and then I'm going to transmit on pin 26. Create the same while loop here, and then basically if pin in is high, is what that is saying, is true, is high, is 1, print the switches on, and set the red light to GPIO high. Otherwise, print out the switches off and set it to low. Wait a 1/10 of a second, start over again. So,
yeah, I mean, you're using Raspberry Pi, but I think it makes sense when you're looking at the program. It doesn't just seem like an overly complex light switch like you're saying. It makes sense.
Yeah,
that you're
it's
wiring that switch up, it senses the switch, and then it gives you feedback that you've sensed that switch is on.
yep. I mean, and that's like the basis. I don't know if you've seen these projects, but there's a lot of projects around. Is my garage door up or down? Well, you use some sort of input method into a Raspberry Pi or a BeagleBone or an Arduino, and then you basically have it react to that. If you use a micro switch or something on the door, or you use some sort of like that sensor you showed with the two little the proximity sensor type thing.
Mm-hmm.
You could use something like that and basically say when it reaches this value, go ahead and call it closed. And if it's below this value, call it open.
Okay.
So it's just, it doesn't kind of matter what you're inputting in. There's only two kind of inputs really on these hardware devices. There's an analog in that's variable input. That would be something like I want to put a microphone connected to it and read the frequency of the microphone and the voltage that's going into it. Or this is just digital. It's ones and zeros. This line of code basically says GPIO is 1. Okay, great. Then do this. Else, it must be 0. Therefore, do this.
Okay.
So, I got this one. My AKA turn the blinky thing off. So that's important. So, and then the last thing I've got to show here is actual Pi traffic. So this is it's basically a recreation of Craig's code. Again, I put a scaling variable in here because I have no patience for waiting 10 seconds for a light to change, whether I'm driving or I'm sitting here watching the board, either one. Same libraries being used. Again, I'm naming the pins. I've got my pin in 18 here, my scale variable, my same board setup code here. Then I'm setting up my lights. I actually did it the hard way here. I don't know. I think I wrote this before I wrote the other ones. But I could have written it the way I did before by putting all those pins in a list and basically feeding the list to the method. You can feed a tuple in there as well. I'm not sure if there's any advantages to that or not. I didn't really discuss it. It was like you can use a list, and oh, by the way, you can use a tuple in the documentation. So set both lights up, set my pin in up, and then I've just got another big while loop here that's going to run over and over again. And when I press that button, it's going to wait 5 seconds or some scale of 5 seconds. Then it's going to start executing this code, and this is where it gets a little messy, right? So I got output. So my first move it makes the first light go to yellow while leaving the second one on red, GPO high. And then at the same time, I have to make sure I set all the other pins low. Then I wait, and it cycles through this whole pattern, the same pattern that Craig had. And then when I get to the end, my else statement is basically the default pattern, or the way I want it to be when I don't have the button pushed, which is the first light's green, the second one's on red. So, well, let me show you how that works. Where am I going here? Here, go. Well, that's what I want. Okay, let me run this code. Okay, so now it's in the default mode. So we have the first light's green, second one's red, and then when I push this switch, we're going to wait 2.5 seconds, and then we start cycling through the pattern.
Okay, cool. And then it goes back, cycles
back. It just goes back and, yep, and just waits.
Nice.
So, and the lights go off, which is always good. So, I don't know. Is there any questions or anything? I keep turning my camera off. Sorry. Any questions about the code or? I've got the repo out there. I'll probably add some stuff to it, like the links to the documentation. The documentation was actually down about an hour ago. It's on SourceForge for some inexplicable reason.
Ooh.
Yeah. And so I couldn't do that. I got to finish my fritzing drawing, and so when I do that, that'll have the header on it that is different. It'll have the cool thing about this little header thing. I bought this from Adafruit, and it's got all the pins labeled on it, so I don't have to think about how are those pins laid out on the actual board. I can just look at the labeling. It's called a Pi Cobbler. So
what does it
it's
do?
pretty cool. It basically takes the 40 pins off of the Raspberry Pi and allows you to put them on a breadboard like we have here. And it just comes with a ribbon cable so you can connect it. But the real key is it's got every pin labeled on the board, on the board that it's sitting on the breadboard. So I can look at that and go, okay, where, you can imagine if you had to, in your mind, interpret between where this ribbon cable is hooking up in the actual Raspberry Pi. So that's the most valuable feature of that thing, because otherwise I would be sitting there going, okay, well, it's 5 pins down. Now let me look at the diagram, and try to figure it out. You don't have to do any of that. It shows there's actually this thing. It's putting out 3 and 5 volts both. Shows where the 3 and 5 volt pins are, where your ground pins are. There's actually MISO, which I can't remember what that stands for. So it's got a certain dedicated serial out pins. So if you wanted to connect to something with a serial interface, you can. So, but the great thing is it runs Python. So if you want to read something off of a USB device or something, you can do it. If you want to make it serve a webhook to a database, you can do those things. So.
Seems like a lot I could do with that, but I just haven't come up with a project yet.
Start with a stoplight.
That always seems to be the problem, coming up with a project.
Yeah. There's so many cool ideas, but
I'm getting way into the stoplight thing. This version of the code you saw is actually like a dumbed down version of what I have pluses for intersections and rail crossings. See if I can make them talk to each other, if there's a train at the rail crossing, we want to make sure the light in this direction's green, but this direction's red, that sort of thing. So I'm going to have to build a model railroad setup or something here in my house just to test it out. The wife will go crazy.
That would be pretty cool, though. I mean, that would be the ultimate demonstration, right? Because it looks like real life.
Yeah.
Yeah, that was kind of my ultimate dream for this would have been to get a little setup where I could roll a Hot Wheel over a pressure sensor or something like that, and then have it trip the light for you, So if you've got them in your little kit, you got these paper thin pressure sensors that got 2 prongs on them, and I could have used that. I've got a couple of those. You could have used that in the place of the switch, and then you put something on it, or you press down on it, and it'll trigger it. So. It's
I expect to see that next week.
It can be a rabbit hole. I think I spent about 3 or 4 hours yesterday just playing with this thing, going, okay, let's make this lights flash this way. Okay, what if I do that? Oh, and then I got into that whole good, better thing. I was like, well, I could write it this way. I could write that way. How many ways could I write the same functionality? So.
That's cool.
Yeah. It takes up a lot of time. But
I could definitely
the possibilities are endless, especially with the whole Internet of Things. So yeah, you're sitting here going, well, gee, what do I want to monitor? And I believe you actually have 26 pins here that can be inputs or outputs. So plus a serial interface, which then just gets a whole mind-blowing array of things you can do with that, And so you could basically have a Raspberry Pi security system or, something like that.
How would you do that?
Basically, you could each of these inputs, there's actually tutorials I've seen online that in security systems they have those proximity sensors in them. They actually sell those separately, and you just wire one of those up to this. You could wire several of them up to this.
Okay.
I believe you could use a serial interface to read those. If you wanted to, this thing's on the internet. You could send yourself a message using Twilio or something like that. If something happened at home, you could put a private web page up where you could log in and watch a video. This thing actually has a camera input on it, and you can connect a regular USB webcam to it. So,
and
4 of them, in fact, because it's got 4.
And you can hook up a deadbolt to a servo that's controlled by it.
That's true. They've got the locks that are already set up for that. So now the issue with a lot of this stuff is the proprietary stuff is, everybody, and so that's bred a whole group of vendors who are trying to be cross-standard. When ultimately, I think it's like open source that, why does everybody gotta have their own door locking standard? They're
It'll
what I've
happen.
seen. Yeah.
It'll happen. They'll come to a single standard. It might take a little while, but it'll happen.
I think out of security's sake, they'll end up having to do it because from what I've seen right now, I mean, kind of like Hackaday.io or whatever is one of the blogs I read pretty frequently. There's constantly stories on there about how to hack door locks and things like that, electronic door locks and cameras. Stories of like, hey, if you go search this on Google, you can find everybody's security cameras that are open to the internet.
Yeah, and you actually can use the Samsung SmartThings platform. They have like a bunch of different sensors for home security and automation, and that ties directly into Raspberry Pi with an API that you can just program with Python.
Nice. I was going to ask that if there's any
Cool.
so there are all those Internet of Things kits out there now. I was going to ask if any of those tie into like Raspberry Pi, and then you could just do the programming piece of it and have the hardware already made.
Hey, we're in Marches for Makers. You're supposed to be doing stuff for that hardware.
Oh yeah.
Yeah.
Whoops. But no, I think
for
that's
the next few hours.
for the next few hours. That would be cool. You said it was the Samsung kit?
Yeah, it's Samsung SmartThings.
Okay. I'll have to look into that.
Yeah, that's cool that they've done that. I mean, it's always a shame when
OpenHab
is
also another platform that you could use. It's more of like the software side of it, and then you could use random things via OpenHab, but that's another home automation that you can use with Raspberry Pi and Arduinos.
Okay, cool. You said OpenHab?
Yep, OpenHAB.
Okay, cool. Thank you.
The thing that really scares me about a lot of this stuff is how security hasn't really been figured out yet. I mean, there was that big deal last summer where the security researchers hacked into, I think it was a Jeep that was a couple of states away, and they were able to shut off the engine.
Very.
And all they needed to know was they were able to connect to that direct one because the guy driving the car gave them some sort of ID, but they could have just pinged everything and shut down a whole bunch of cars.
Security, and I know Charlie Miller, the guy that does the research there. He works for Uber now, which is funny. But the thing about it is that like the vulnerability is actually on the Jeep Cherokee side. It's actually the protocol that they were using is vulnerable. So basically, all he had to do was spew out to the internet, "Hey, all of the Jeep Cherokees that are connecting back to Jeep, tell me where you are. And then that's why he had to find out what ID was the actual vehicle, because he was getting every Jeep Cherokee
Oh
within
no.
range of internet signal. So that was the scary part.
So his shortcut wasn't to let him in; it was to narrow the scope of what he was doing down to a single one.
Yeah, he did
Yeah.
a talk at DEF CON, which I went to and did it. Yeah, it was pretty scary.
That is.
I thought I heard something about them also. I don't know, maybe it was a different one, that somebody was using an unsecured Bluetooth connection in the vehicles, and if you were close enough, you were able to do things like unlock the doors and stuff. I don't know. Did you hear that? Or
had a vulnerability. I think Mercedes had one. Actually, a lot of these. The thing is, over time, they're going to get better, but it's really ubiquitous encryption is probably 99% of what it is that you can see the traffic, so then you're able to discern what's the vulnerability versus seeing gobbledygook and having to know a secret in order to figure out what's going on. So that's really 90% of it, is that just encryption isn't required for a lot of those guys.
yeah, I remember several years ago I was kind of getting interested in this sort of stuff, probably maybe 6 years ago or something like that, and I just go buy a development kit from Texas Instruments to develop on the control boards that run the cars. So actually, my day job, I work at Caterpillar, and we deal with Navistar and Ford engines and stuff, and like those all have a Texas Instruments control boards in them. That same one I could go get a development kit for, and I mean, you figure out what all the pins are, and then how to do weird things to the car, like cause the anti-lock brakes to come on when they're not supposed to.
Wow.
Yeah, it's crazy.
I'm gonna buy an older car.
And then upgrade it with an Arduino.
Yeah, but I mean, all that stuff is really cool. I think that the ability to do all that stuff is cool. It's just, like you said, making sure that it's behind something secure rather than being able to just kind of break in and do what you want to do.
Yep.
Yeah, I guess you have to think about it. And back in the day, people didn't have locks, so theoretically, in the olden times, theoretically, you could just walk into someone's house and take whatever you wanted from them. So think about the Internet of Things like that. And over time, as people get burned and robbed and stolen from, or even killed or something crazy that, those locks are going to start coming in very, very quickly. But I think a lot of people are trying to think about that stuff prior, and that's where you get the thing that Charlie Miller did was called stunt hacking, which scares a lot of people because it's on TV and it's the cool part of hacking, I guess. And that's what got publicity, and people to start thinking about that stuff. Other than that, if someone was just going to write a very long paper, no one would read it and no one would be worried, and then some bad guy would do something. So I think that's really unfortunately, where the industry goes.
Yeah, I think that makes sense. I mean, you can overreact to that, but at the same time, you could look at it as an opportunity that there need to be people who understand security in these modules, and maybe that's something that you could, if you had an interest, go figure out and help people with. Now I want to go look into that. All right. So thanks for the demo of the Raspberry Pi with the stoplight. That was really interesting seeing that and seeing how you could set it up on a different set of hardware as opposed to the Arduino. There's a lot of similarities, but at the same time, there's a couple different things. So.
Yeah, it's definitely a much more capable piece of hardware, but I could essentially unplug this header, plug my Arduino in it, and run the same demo. The hardware stays the same, just the thing it talks to it changes, and it becomes a lot more powerful when you run a full board computer.
Yeah, that's cool. All right. So outside of that, what's everyone been up to? Anything? Other than putting together a really cool demo for tonight, have you been doing anything?
No.
That's cool. Yeah, I've been busy too. TJ, what about you?
I've been working on a couple Python projects. One actually I have on GitHub. It's basically a Python script that calls the. Have you guys ever heard of PacketPub, the technical book
No,
store?
no. What is that?
It's packetpub.com, I think is what it is, and it's just basically a web. It's like a O'Reilly. It has a bunch of books on programming languages or security and all that stuff, and every day they give out a free book. So I was like, I can't be going to this website every single day. So what I did was I wrote a Python script that goes into the website, logs in for me, and if the book is something that I don't have currently in my library, it'll actually go and download the book. And it's actually running on a Raspberry Pi mounted to the back of my TV right now. So I can post a link to the GitHub.
Yeah, that would be cool.
The Code Newbie.
I think it's Packed Pub. Is that what you were talking about?
Yeah, PacketPub, yeah.
Yeah, I just posted the link to the free. I go there every day and look at their books.
So
So.
if you use that Python script, it'll actually save you a little bit of time because I have it on a cron job on my Raspberry Pi. Every day at 8 o'clock, I'll pick up the new book, and I have a lot now, so it worked out well.
That's really cool. I've been really interested in automating stuff, and I guess like the hardware projects, it's kind of like what should I do? What should I do? I don't know. That's a good example of how you can just set something up to automate, and it really helps you out. You don't have to go check it every day. It's just going to automatically do it. I like that.
Yeah, I love automation, and dashboards are like the thing that makes me excited about Python. Is just like being able to just have like a web ready programming language, and then also do a lot of stuff from like the electronic side with the GPIO that you were showing today, Jamal, and they'll even do things from like a system side and being able to tap into the C libraries. It's really cool language.
Nice.
Yeah, have you ever seen those projects where this is one of the early Arduino projects I saw in a lot of places, which was they would make a Gmail notifier that used a servo, and every time you got email on Gmail, it would raise a little flag. And so you could actually take your pack publishing thing and put a little flag on a servo, and look,
Ding.
Did actually do that. I should.
My book's here.
I should have an indicator on there, an indicator light or something.
Yeah, you could wire up an LED to it, or the actual Arduino has a touch screen you can get for it and stuff. It's really cool. You can actually build little cases for them and basically create tiny little tablet computers with them. So you could have one you just carried around that downloaded the book to it when it automatically came in. You could read it right on there.
Yeah.
That would be awesome. I want to have a little flag and put a little button next to it, right? So that I come home from work or whatever, the flag's up, and then go check it out, push a button, goes back down, and then, 3 days later, it's another topic that I'm interested in. Oh, I got a new book.
Actually, it worked out really well because it gives you like the books as in like in your account, so you can go in and I actually have another script that I didn't publish that automatically takes it and emails it to my Kindle, so I can search through like if I need a random obscure term or like I guess like list comprehensions. If I had to look up something like how to do a list comprehension in Python, it will search through all of the ebooks that I have, which is a lot now, and it pulls up the book that has it in there, and it just automatically gets there, which is the reason why I wanted it. Is just literally a library of data when it comes to programming, and there's a lot of electronic stuff too there. They do Python robotics, Python. They do Python web development, which I love too. So it really works out. It really works out well.
That's nice. It's almost like you've written your own like DIY Safari type library.
Yeah. I'm pretty damn close to it actually. Like I have a lot of books.
So TJ, you mentioned system level programming. So there's a YouTube video of David Beasley using Python to hack on a 1978 computer.
Oh wow.
What?
If you could post that, that would be awesome. I'll try to search for it now.
No, I put in the links. He used its modem? No. It was one of the computers that used the old audio connections.
Uh,
And
Okay.
he programmed his MacBook to act as a modem and send data to it, to and from it, using the audio connections.
That's crazy. Yeah, the stuff that people do, like even I'm in information security, and like people reverse engineer in Python. Like you can do a lot of stuff with Python. You have pretty much full reign of any system with Python, if it's on there.
Yeah.
So Derek, you also posted, I think it was earlier today, or maybe it was yesterday. I don't know. An obfuscated Python. I didn't know people did obfuscated Python. I thought that was just a Perl thing. But you posted that up, and honestly, I couldn't read it. I mean, I could read the article, which did a good job of kind of explaining what they were doing, but
Yeah, I had never seen obfuscated Python before either. I'm actually more used to seeing obfuscated C, where they're really good at making it look bad. Things like I saw a program for playing Tetris, and the code was laid out to look like a Tetris game with a block falling down.
Wow.
Really?
Yeah.
That's crazy. Huh.
The
Let
one
me
thing
see.
I actually saw, not that you're asking what I did, was the thing that almost derailed this demo was the thing I posted about machine learning yesterday on the Google's launching a free machine learning class, and it's like the first video is 6 minutes or something like that, and it's like machine learning in 6 lines of Python, how to tell the difference between an apple and an orange. It's amazing.
Wow.
I had to really hold myself back from just like going down a rabbit hole on machine learning yesterday after I saw that. So
When is the right time to stop yourself from going down a rabbit hole, and when is the wrong time?
when you're trying to make marches for makers and you want to do it well, that's about it.
I've been struggling with that too. It's like sometimes I'll go down one path and I'll end up over here, and then I'll be like, oh wow, I didn't know that, and I'll end up over here, and I'll be totally in a totally different place. But I've been trying to figure out when I should stop myself from doing that and when it's okay to do that.
Yeah, I don't think there's a good solution to that problem.
I guess deadlines are one time that I should avoid that. But
Yes. All right. Here's a good obfuscated C.
okay, what have you got?
Uh,
What? That's just like ASCII art.
yes.
Here, I'll throw it up on the screen so anyone watching could see it. Screen share. Oops, wrong button. Try that again. There. That's like a little dragon dude.
Yeah.
So, what? It looks like there's code in the middle block, right? But then there's also like numbers that look like they have some kind of meaning on the outside.
I've never actually tried to parse one of these by hand.
And then there's like comments going on there or something. So
Yeah, all of those numbers are comments.
Huh. That's pretty crazy. I don't even know how that would work, but it's almost like code art thing. I don't even know how
Yeah,
to
I have
describe
no
that.
clue how people think of it. Like, that's there
Yeah.
for like, hours.
Exactly.
And then, like, you mess up one thing and you have to change everything so that the algorithms work. Because, like, you're doing translations, and it's, yeah, I have no clue how that would.
I almost want to like print it out and
It's
hang it
like
on my wall, though.
the game. Have you guys ever heard of Eve, the game?
Yeah.
Eve Online. So one of the reasons why early on it was having so much trouble was it's made in Python is because it's so easy to read the Python code that people were just able to like figure out vulnerabilities and inject Python into the game and sort of break it. I call it Easter eggs because if you're able to legitimately figure out, then all the power to you. But like that was like one of the things that like was a reason why it was so hard, like it was so easy to break into.
Huh. That's crazy what you can do with this. All right. Well, let's see. It's been a busy week. I really didn't have anything else prepared for tonight, but is there anything anyone wanted to talk about?
I got a question about that C program. What does it do?
I don't know.
I tried compiling it and running it, and it didn't seem to do anything on a command line anyway. I probably completely hosed my computer, but hey, it was worth it. I was kind of hoping something super cool was going to happen, you know.
Yeah. Your screen shows a flying toaster or something.
Yeah, I mean, that's
You
almost
can't make
like
it
putting a
stop.
great paint job on a car and then the thing doesn't run. So
Yeah, I don't know.
it throws a
There's
ton of
the,
warnings when you run through GCC. I tell you that much.
yeah. There's the make file. Actually, if you just go to this site,
Well, the make file is almost longer than the code.
you go to that one and grep for Hamaji. There are all the files that go along with it. And you know it's good because, oh, dear God. You know it's good because there's a Perl script that goes along with it.
I didn't know that was a sign
the
of good
mark.
code.
That's the mark of good obfuscated code.
The Perl script is even more indecipherable than the C.
I'm looking for it.
Yeah,
Where is
it's
open with. What does it's uh the Perl shorter.
Yes, yes, it is.
It's doing something with regular expressions.
Yep, I got that too.
And there's a loop, and it prints something, and I think that's all I've got.
Yeah. From 18 to 75, it prints something.
Yep. Huh. Yeah, I don't know. What is a dot no? Is that for translating all that stuff on the side?
I got nothing.
Yeah, I
Oh,
don't
those
know.
are the files you can pass into it.
Okay, so it does something with those?
Yeah.
Okay. That's crazy.
Oh, wait a minute.
If you
This
try
says
to...
this is from the International Obfuscated C Code Contest.
Yes.
I like looking at the install or the make file. If you try to do a make install, it says, "Surely you're joking, Mr. Fabian." It won't let you install. There's even an Easter egg. All right, I gotta stop staring at that. Oh. So I am about to play with my Raspberry Pi. One of these days this week, sometime soon, I'm going to try to get Sonic Pi going because I want to do a demo at the next meetup, which is coming up in like a week and a half. That's written in Ruby, and it allows you to live code music essentially in Ruby. So I think that's my next project.
Yeah, actually, earlier this year, I made a Raspberry Pi photo booth in Python.
Nice.
A tutorial I found online, which works pretty well in my space.
So you hooked up a camera to the Raspberry Pi, and then it'll take a picture when you trigger a picture somehow.
Yeah, so I hooked up the Pi camera to the Raspberry Pi, and I have lights, the indicator lights, and then also it uploaded the pictures to Tumblr.
Oh, nice. So it's a full camera booth.
Yeah. So people pressed the button on the top, and then it was like it counted down, and I actually used like image magic, pretty much the whole gambit of of libraries. It was really fun. I have to fix it now though, because we decommissioned it to take some parts to use on something else. But now it's all that project's all done, so I want to bring it back together and actually put it back together again.
That would be a fun thing to just kind of have in the corner of your house or corner of I don't know, somewhere like work area or something, where whenever you wanted to, you could just go over and photo booth a selfie.
Yeah, if people still did the one picture a day thing, that makes it really easy.
Yeah, you could build a whole blog around that or a whole Tumblr
Yeah.
around that. Huh. I want to do that too. Photo booth. Well, once I get the Sonic Pi going, I might bring that here, even though it's Ruby, and see if I can get that going on a demo, because that would be fun. Right. Well, unless anyone has anything else, I think we can probably wrap it up for tonight, and then we'll be ready to do some more Python next week.
It's fine with
Right
me.
on. Cool. Well, thanks everyone for joining. Glad you were able to make it tonight, GJ. Hope to see you next week.
Cool. It was awesome. See you guys.
Sweet. Yeah, have a good one.
Yep.
All right,
Bye.
take it easy, Larry. Thanks for doing that.
Yeah, no problem. Thanks for it spurred me on to do something. So
Nice.
always good to have a deadline, like you were saying.
Yeah, for sure.
All right. See you next week.
All right, have a good one.
Yep.
And I'll throw up the links to all this.